Heinrich. I'll be your host, essentially, for these 9 weeks as we delve into the topic of consciousness. And particularly delighted to see such an interesting and varied audience. We've got ambitious Stanford students, Stanford professors. We even got some really interesting community members. We've got some Google engineers amongst us. We've got senior VPs and CEOs of Fortune 500 companies, as well as startups. We've got meditators and non-meditators, so a really interesting group of people. But before we get started, I'd also like to sort of thank a few people that have made this possible. First, our course advisors, one of which is Dr. Cesar Molina. He couldn't be with us today because he unfortunately had travel booked before this course even was announced to him. But he did his residency at Stanford. He practices at the El Camino Hospital, and he's also the co-founder of the South Asian Heart Center, which really is all about prevention through lifestyle change, and sort of rest, diet, etc. is really part of that regimen. Another course advisor is John Bright, who is with us here today. Thank you, John, for all your support. And he is one of the leaders of the International Transcendental Meditation Movement, TM for short. And of course, Andrew Todhunter, who because of travel schedules is also not with us today, but he essentially is our course sponsor. He lectures in the Department of Biology and Creative Writing, and he's a really prolific writer, filmmaker, very, very creative, and really made this possible. And of course, the Department of Biology and the head of biology, Bob, for sort of making this possible and sponsoring it. So let me cover also, actually, let me also thank the Stanford TM group for sort of their support, helping market this. And you guys are awesome. Thanks for always showing up for group meditations. So thank you for your support as well. So before we get started, let me also cover a few logistical things. If you've signed up for the 1-unit course, you're allowed to miss 1 session, since we only have 9 sessions together. You know, ideally, I'd like to see you as much as possible. I understand if sometimes you have some conflict. But if you wouldn't mind, and essentially put down your name and also your student ID to make sure that I have a record of you being here, then I can sort of make sure that you've actually attended the class. And before we start too, do you have any questions about logistics, how the course will run? Any questions at all? Good, everybody. Oh, some question back there.
Is there anything else required for attending the session?
Ideally, you do also the reading, the required reading. So on every speaker will have their biography and usually some type of piece that they've either written or some piece written about them. And at the end, we also ask you to do a reflection piece, just a 1-page paper essentially about what you've learned in the class or some piece of the reading, something like that. So we really want to make it fun, so you can choose the medium. It could be a website if you wanted to. It could be just a paper. It's up to you, really. Other questions?
We've already max credits. Can we audit this course?
Yes, you may audit this course. As I said, it's also open to the community because we invite sort of a really high-quality audience so that we can really push our speakers on this topic of consciousness and to really see, you know, how scientifically validated it is. You know, so it'll be a lot of fun. So thanks for coming. Yes.
Is there a syllabus?
Yes, there's a syllabus. Were you on the initial email?
No.
Okay. Are you registered for the course? Or?
Not yet.
Okay. So have you signed up for the Google form that I sent out?
No.
All right, just leave your email with me. I will send you a syllabus. All right, let me pass this through. And if you're a student, please sign in. And if you want, you can also leave me your email address in case you have not signed up for the Google form. Any other questions? Good, so let's dive into consciousness. So hacking consciousness. How did this come about? So I've always been fascinated by the topic of consciousness. As an undergraduate, I studied cognitive science. And the predominant worldview there is that this physical thing, the brain, this part of this that's matter, gives rise to mental processes. And these mental processes are then considered consciousness. But I always found that answer somewhat unsatisfactory. Because I asked myself, well, doesn't a flower have consciousness? Doesn't a tree have consciousness? I mean, there's some organizing power, right, to a flower or to a tree. What is that intelligence that makes a flower bloom? And then I also I've always been really fascinated by meditation techniques. I've tried Qigong, I've tried mindfulness, Buddhist walking meditation, contemplation meditation, Zen meditation. And I always wanted to dive into this idea of consciousness. And what I noticed is that when I think a thought, I can actually be conscious of me thinking a thought. So who is actually that observer behind that thought? And that's where sort of this whole interest came about in terms of hacking consciousness. And after undergraduate, I worked for a while and sort of forgot about this topic until I found myself working for a man named Ray Dalio. I don't know if you guys are familiar with him, but he runs a company called Bridgewater Associates. It's one of the most successful macro hedge funds of all time. And he said that he's been practicing this meditation technique called transcendental meditation for 40 years. And he said that that is one of his keys to success. And I said, that's a big endorsement, so why don't I try it out myself? And through there, again, got exposed to this topic of consciousness and really found myself, again, experiencing as well as getting intellectual knowledge about it. So I thought, now that I'm at Stanford doing graduate studies, why don't I have other people participate in this journey and really see what consciousness is all about? Can you access it? Can you hack it? How do you hack it? And those are some of the questions that our speakers will address over these 9 weeks. Which brings me to Dr. John Hagelin, who is our esteemed guest today. I could probably spend 5 minutes introducing his background, but I won't do that. So I'll just mention some highlights. He is one of the most cited quantum physicists of our time. He has written over 100 research publications of that sort. He has done groundbreaking research at both CERN and SLAC, our very own SLAC. He's been part of many movies, including movies like What the Bleep Do We Know, has had many TV appearances, and this list goes on and on. So I'd rather just have you hear from John Hagelin himself. So please give a warm applause to
I'm not mic'd. Can you hear me okay back there? It's great to be back here. Sunny. Campus looks wonderful. And what a great audience. I haven't even talked to you yet, but just the description of who you are should make this a lot of fun, certainly for me anyway. We're going to be introducing the subject of meditation basically from a very classic perspective from the yogic tradition and from there ultimately the Buddhist tradition. And in the context of that, talking partly from the standpoint of a fundamental physicist, what consciousness is, or at least what we think it might be, and ultimately experiential access to it. Consciousness, I'd have to say, is really self-hacking, but how do you hack it? So in the process, I'm also an astrophysicist, or a half-astrophysicist. I like to always spend a moment locating ourselves in the structure of the universe, and here, of course, are the, I almost said 8 planets. I grew up with 9. It's a sad story. And here they are in relative size to each other. They are certainly spaced farther apart than they look like in this. And our solar system is a pretty marvelous example of a solar system. We tend to be quite fond of it. It is our own, and we do live here. That's what Saturn looks like Jupiter, a gas colossus, a hydrogen and helium star, about 500 million miles from the sun, about that distance from us as well. And it doesn't take much of a telescope in your backyard to see that incredible jewel out there like that. This is the ice world of Neptune, now the last, the 8th of 8 planets. That's what the noonday sun looks like from Neptune. It's a little like Iowa in the winter. Don't get much of a suntan there. And that's our solar system. Of course, we're living in a galaxy, the Milky Way galaxy, with about 400 billion suns. Most of those, we think, with some kind of a planetary system, not all. And in this sort of island universe, in this rather flat or pancake shape, and within our Milky Way galaxy, which is that stripe, you can probably see, the sky is good enough here that on a clear night you can see it, incredible things happen, like stellar explosions called supernova, which are responsible to final last gasp in the life of the star that can result in this kind of cataclysmic explosion during which the heaviest elements get cooked, like gold and platinum, anything heavier than iron, thrown out into space, contaminate space with heavier elements, because it really started as hydrogen and helium after the Big Bang. And from those heavier elements blown out into space, new stars form and planets form. Not just gas planets like Jupiter, but the Earth, made of dirt, silica, iron, etc., all come as remnants of supernova explosions. Our bodies, comprised of things like oxygen, nitrogen, carbon, were not cooked during the Big Bang. They were cooked in stars and then blown out into space from where our planets and our bodies were ultimately taken. If you take your backyard telescope and take it away from the plane of the Milky Way, out in the direction of deep space, and if you have a good telescope, you see this. You see more galaxies than stars. And each of these galaxies, remember, has several hundred billion suns. And you kind of get in a state of awe, kind of a state of wonder. What enormous intelligence is this? What incredible creativity. What are the laws that govern it? And that's one of the quests of science and astronomy, all science actually, to understand the fundamental laws governing the universe. So that's it for outer space. We're going to spend the rest of our time looking at inner space, the structure of reality at deeper and deeper levels. That means, in the language of physics at least, smaller and smaller space-time scales. And one of the things we've learned, one of the most important things we've learned from the last 100 years or more of physics is that the universe is structured in layers of creation, from superficial to fundamental, from macroscopic to microscopic. And that inward exploration started at a very surface level, 300 years of classical mechanics dedicated to the study of macroscopic matter, but turned about 90 years ago towards the exploration of the deeper world of the atoms and molecules, the world of quantum mechanics. And what we discovered is a little surprising and probably not what you learned in high school, maybe what some of you learned in college. And that is that the atom is not a billiard ball and not a solar system in miniature. In high school, they maybe say that, well, the sun is like the nucleus and the planets are like the electrons orbiting the nucleus. It's a quaint picture, but it has absolutely nothing to do with reality. It serves no purpose, and it doesn't work at all. The quantum mechanics is a whole new language, a whole new logic, a whole new mathematics that is subtler, more expansive, more profound, and appropriate to describe physics at this more fundamental level. Very soon, physics went on to discover the atomic nucleus, to explore the nucleus and the fundamental particles that comprise the nucleus, quarks and leptons, and a whole new language was needed for that. Not a radical departure, but a substantive departure called quantum field theory, which is the marriage of Einstein's relativity with quantum mechanics. Again, though, a whole new formalism, a whole new mathematics required. And then ultimately, certainly the hot topic in physics today, as it has been since the superstring revolution swept through here about 20 years ago, is maybe 25 years ago, starting with supergravity theory, is unified field theory, which in today's more common parlance is typically in the form of superstring theory and M theory. These theories are very exciting for reasons I really wish we could get into in great depth. I'll mention a few things. These theories fulfill Einstein's lifelong quest to discover the unified source of the diversified universe, the unified fountainhead of all the laws of nature that govern the functioning of the universe at every level. Mathematics of this is extremely daunting, even though the fundamental reality is one of absolute simplicity. The mechanics of the expression of that fundamental unity into the diversity of the laws of nature is a rather complex, very nonlinear process involving self-interaction in a very non-trivial way. But speaking qualitatively instead of heavily mathematically, the fundamental nature of this field of unity at the basis of all diversity is absolute silence. Absolute abstraction, almost. You could say pure existence, pure being. But it's not a field of inertia. It's not a field of death, I would say, because the quantum principle guarantees that intrinsically this field is dynamic. In fact, the quantum principle, or uncertainty principle as it's known, is the principle of increasing dynamism at fundamental scales. The same reason nuclear power is more powerful than chemical energy, even though in some respects it's very similar, but it operates at a level that is 1,000,000 times smaller, and therefore operates at a level of nature's dynamism that is 1,000,000 times more powerful. Due to this intrinsic dynamism of this universal field, the field is actually, well, you could say silent at its core, but it's roiling and boiling on the surface of life, erupting in this effervescence of what look like effervescent bubbles emerging from ginger ale. That's sometimes called zero-point motion. These days it's called, or vacuum energy. These days it's called dark energy, because it's this type of activity that is driving the universe today in this ever-accelerating expansion that has been relatively recently discovered. Now, for the astute audience, and most of you are certainly in that category, you probably have surmised that these bubbles aren't ginger ale, actually. But they are these little rubber bands, these little loops. They are infinitesimal loops called superstrings. Little rubber bands, literally relativistic rubber bands, infinitesimal. And I know it's kind of depressing for those who are seeking the ultimate nature of reality to conclude that after all these years of profound philosophy and scientific research, we've discovered that the whole reality of the universe is a rubber band. But it's not really what we're saying. It's not the rubber band that is fundamental. It's this universal field of intelligence, this intrinsically dynamic, self-interacting field that percolates superstrings. And these superstrings are what we used to think of as particles. The fundamental particles and forces of nature, in the context of these theories, are just the different vibrational states of these rubber bands. Now, there's a certain type, you can sit down and you can examine the physics of a rubber band. You can count the different vibrational states, the different modes of vibration that a string, a rubber band, can vibrate in, and you'll conclude that each of those vibrational modes of a rubber band has its own frequency, its own natural tone. That type of mathematical physicist that undertakes this calculation of the enumeration of the vibrational frequencies of rubber bands are called nerds. But they're very, very But the miracle of superstring theory, just honestly simplify things quite a bit for the sake of time, is that these different vibrational tones, these different vibrational frequencies of these fundamental superstrings, each frequency corresponding to a different energy, as Einstein equates, well, frequency, of course, and energy, and also Einstein equates energy with mass. These different rubber bands, due to their different vibrational modes, have different amount of energy, which means different amount of mass. And when you look at those masses and the other properties of these vibrating strings, lo and behold, you discover that this is a universe of just certain types of particles. One of those vibrational tones acts like gravity, a particle of gravity, a graviton. Another one acts like a particle of light, the spin-1 massless photon. Another one looks like a spin-1 half quark, or an electron, and so forth. And you get just the categories of matter and energy that we know and love, that are the building blocks, so to speak, of the universe. So that's kind of an amazing prediction. You start with a relatively simple principle, I would say deceptively simple to be fair, of a vibrating relativistic string, and from that you conclude that the universe coming out of such a field, percolating these strings, looks like ours, or at least roughly like ours. But it's a very different view of the universe. It's almost like this universal field, like a guitar string is a one-dimensional field. Surface of a pond is a two-dimensional field. This is a three or more dimensional field. But fields have their own vibrational states, call them waves. And depending upon how the field is vibrating, depending upon the frequency of the wave, that wave will behave like a graviton, a particle, a so-called gravitino, a spin-1 force field, a spin-1 half fermion, or the newly discovered Higgs boson. There's an interesting relationship which I can't begin to touch on today that these five actually correlate in a very precise way to one of these ancient, these quaint, ancient, prosaic theories of the universe that's comprised fundamentally of five elements. And that's an interesting point, perhaps, for another day. Finally, I'm going to leave physics in a moment. I'm sure you would leave. In addition to these superstrings that percolate from this time translationally invariant, this sort of ocean of immortality, ocean of pure being, are not just these superstrings and not just particles, but entire universes. To the current ability of ours to calculate in the context of such theories, there is a finite probability that whole baby universes will emerge from this bubbling cauldron of what is called space-time foam, and most of those are duds. They disappear almost immediately in a burst of energy, but given the right initial conditions, they grow, some of them will grow exponentially, expand enormously, and that is called inflation, the inflationary universe, the Big Bang Theory. If you look at this picture carefully, you will see that there are several of these going on as we speak. And some of those survive. And if you do the math even relatively simply, you would conclude that there is, depending upon a few assumptions, probably an uncountable infinity of simultaneously coexisting universes continuously erupting from this enormous universal ocean of intelligence. And that is called today the multiverse, a scary concept. I'm not in love with it, but is a concept that is sort of getting forced upon us as we look more deeply into the nature of this fundamental physical